Hi friends, today we will discuss on a very fundamental component in electronics which is called a transistor. So what it does, a transistor is a device which will do two fundamental applications. One is called amplification, another is called switching. What is amplification? Amplification means a transistor can take a small input signal like from a guitar pickup and produce a much larger output signal, increasing its power and amplitude. So this should be a small signal. We can amplify this to see it should be amplified to get a very large signal as an output. Okay, so if we can use a transistor circuit here, we can amplify this. And second thing is switching. It can be used to rapidly turn electrical signals or power on or off, acting like an electronic switch to control the flow of current in a circuit. So instead of this switch, we can replace a transistor to it like an electronic switch. We can easily on off the circuit. Okay, so what is the key component and structures? This is the schematic of a transistor. This is mainly consisting of a semiconductor material. Okay, transistors are made from the semiconductor materials which can be treated through a process called doping to change their electrical properties. Okay, so we will dope this material. There we can dope it two times. One is called N-type doping, other is called P-type doping. So we have to create a structure like a NPN structure or PNP so that we can properly bias these circuits to get a desired output of this device. Okay, so this is a three-terminal device. We have three terminals. One here, and three is here. So this is called the emitter, base, and collector. So what is the control mechanism? So the control mechanism is a small signal, voltage or current is applied to the base. So we are applying a small current to the or voltage to this terminal called base. Terminal controls much larger current flowing between collector and emitter. Okay, so this is collector and emitter. So what is doing? The very large current is flowing through this collector and emitter. So if we can apply a current or voltage so that we can control the flow of very large current through this channel. Okay, this is the basic principle of a transistor. Okay, so why this is very important? Okay, so the main thing is it revolutionized the electronics. The invention of transistors in 1947 led to the development of modern electronics and replacing bulky and inefficient vacuum tube. Before the inventions of these transistors, we are using vacuum tube, which is very big and it is not very efficient. Okay, it involved two things, which is miniaturization and efficiency. Their small size allows for the creation of a smaller and more complex electronic devices. And second thing is efficiency. The transistor operates at lower voltage and consumes less power and making them ideal for battery powered devices. Okay, these are some of these transistors. All of them are three terminal devices. Okay. Okay. The most common transistors comprised of three layers of semiconductor material, as we discussed in the previous slide, and have three terminals. So first one is called base. The base is the center portion, or it is also called a gate. This controls the terminal. A small current or voltage applied here controls the flow of much larger currents. So as discussed, in base is a small region where which is a P-type material for this NPN transistor. For this case of PNP transistor, it should be N. Okay. Then then we have an emitter. This is called a source. This is a terminal where the charge carriers of electrons enters the transistor. Okay. Through this terminal with the charge carriers enters. And the final one is called a collector or drain. This is a terminal where the charge carriers exits the transistor. Okay, so actually this what happens is the charge carriers, a large charge carriers flowing through this from emitter to collector. Then we apply some type of potential or current here that will control the flow of charge carriers through this one. Okay, so how we represent this one in electronic circuits? We can do this type of symbols. So this arrow outward will represent the NPN transistor. If it is PNP transistor, the arrow should be inverted. That's the only difference that you can identify from the circuit diagram or symbol. Okay, so the transistors are broadly classified based on how they control the flow of current. So there are mainly two type of transistors. One is called a bipolar junction transistor. This is called a BJT. The other one is called a field effect transistor, which is called FETs. Okay, this is normally represented as BJT, and this is called FET. You can find in the circuits. So what is BJT? These are current controlled devices. These are current controlled devices where the small base current regulates a larger collector emitter voltage. So the main main feature of this is current control devices. They come in two main configurations. One is called NPN transistor. What is NPN? A P-type material is sandwiched between N-type material, and also we discussed like in a previous slides, PNP and N-type semiconductor is sandwiched between two P-type materials. The other one is called a field effect transistor. Then they are voltage control devices where the gate voltage controls the current flow through the channel. The FETs are known for their high input impedance. So this have high input impedance and low power consumptions. The most common type is a metal oxide semiconductor field effect transistor called a MOSFET, which is used in nearly all the modern digital electronics. Okay, so if you are considering a junction transistor, semiconductor junction transistor, we have a NPN transistor and PNP transistor as we discussed earlier. So we have three terminals. One is called the emitter, base and collector. The symbol is also already discussed earlier, and this is NPN and this is a PNP transistor. So this is arrow is towards the base. Okay, so if you look at the different configurations we can use in transistors, the transistor configuration describes how a bipolar junction transistor is connected in a circuit with one terminal acting as a common point for input and output signals. So there are three main type of transistor configurations. One is called a common base, another is called a common emitter, another is called a common collector configuration. So this is the representations that I am showing here. One is called a common base configuration. Common base. Base is common here. So this is common to this emitter and collector. So that we provide the ground here on the base, and this is common to base, emitter and collector. The next one is common emitter configurations, where emitter is a common for a base and collector, and we provide the input here and measure the output across the collector and the emitter. Okay, finally we have a common collector configurations where we will ground the collector, and this is common for base and emitter. So we will provide the input in the this side, base and collector, and measure the output across emitter and the collector. Okay. Okay, if we compare different type of configurations, so we will look at different parameters which will be very much important in electronic circuits. So first one, we have common emitter circuits. We have provided this type of biasing here. We have common collector, and we have a common base configurations. Okay, if we compare different type of parameters, one is called a voltage gain. Voltage gain means how much this voltage is amplified. Then it should be high in the case of common emitter, but less than unity for common collector, and common base it is high, same as common emitter configurations. Like a common current gain, if you consider it as a high, and common collector is high and is less than unity here. And if you look at the power gain, this is high for the common emitter, moderate and moderate for this one. Okay, phase inversion is happening for common emitter, and there is no phase inversion for. Phase inversion means if we are providing a signal like this, this will be inverted like this after in the output terminal. So other thing is input impedance. It should be moderate here, and highest for common collector, and low for common base configurations. Output impedance, it should be moderate and low and high for the different configurations. So if you look at this different parameters, we have to choose a particular configurations according to our use, which is the very good parameters we needed. So we can select one of these configuration to operate the transistors to get a particular output.